Creating new services is a common method for malware to gain persistence. How services are started depends on your distribution, and it's a bit of a maze among Linux distributions, I'm afraid. In Unix and Linux-based operating systems, init, short for initialization, is the first process started during boot, as you can see here, after running PS. The default init program has been changed of late across Linux distributions. So if we think about Debian here, so Debian before Squeeze uses the simple systemv style init or initialization method. Debian Wheezy uses the systemv style init by ordering the boot sequence with LSB, Linux standard base header, and starting boot scripts in parallel, which is moving towards where we are now with Debian. Linux standard base, by the way, if you're not familiar, that is something that's been created to reduce differences between different individual Linux distributions to try and make it more similar. So now, and the new approach with Debian Jessie and going forward, switches its default init to systemd for the event-driven and parallel initialization. So let's just quickly run htop, and there we can see the init process and everything as spawned from that. Quit that. Now, if we do ls-la/sbin/init, we can see there that this is actually pointing to systemd, which is what we're currently running in Wheezy. So we're on a PS grepping for systemd, and we can see there how systemd is running. Many Linux distributions have adopted systemd now as the default init system, and quite a few people are not happy with that. It's a bit of a holy war between the old way of doing things and the new way of doing things, but this is certainly the way things are going in terms of it's looking like it's going towards systemd for all of the Linux distributions. So the init program will determine how services start and where you need to look for persistence when it comes to services being used for persistence. You'll need to familiarize yourself with the init program and systemd in this case, and the distribution you're using to understand exactly how services are started. In systemd, you have something called units, a term called units. We can simplify that and think of those as daemons and processes. They're more than that, but let's just think of units as daemons and processes for now. So that's a systemd terminology, units. And you can explore the services in systemd using a couple of commands. So systemctl is the main command that we'll use, or that is available, in order to manage the services in systemd. So systemctl, and then let's look at the loaded services. So then we need to put in list units -t services, or service rather, and return. And there we get a list of our services. So as you can see here, we've got the units. As I mentioned, the units, you can think of these as processes or daemons. They certainly are if they have the .service at the end of them, and that's what we're looking for here. We've just gone -t -type service. So the unit names, where they're loaded, so it's if the unit's configuration has been parsed by systemd and that the configuration is loaded into memory. Active is if the unit has been started successfully or not, so we can see some active ones here, and there's a failed one, so AppArmor is not active. Sub, this is a low-level state that indicates more detailed information about the unit, so we can see here it's failed as an example. And description, I think, is pretty obvious. So we can go down here and look at the active services. We also have a little description there of what those are. And 53 loaded units listed. So Q to quit out of that. Now we can add --all to the end of this, and this will show loaded and inactive services. And if you look here, we can see these orange ones. So these are inactive. I'm just going to another tab now. And we can put systemctl status. And then we can have a look at one of the services that we want to check out the status of. So Let's go down here, see one that we might want to find. Okay, so Tor. Let's see what's going on with Tor. Pop to the tab, get Tor. And there we go. We can see that this is loaded, and it's been loaded from here. This is its service file, and it is active and running. And if we wanted to check to see who it is, we can open Sysdig, and let's filter F4, Tor. And there we go. We can see that it's running there. And in Netstat, we can see Tor is running. And we can look at the init file for Tor. And we can see the variables for why this has started with that command. So that was status. Now we can actually stop the service. And if we have a look, we can see that it has actually stopped. It's not there anymore in processes. It's not there, no port open. And of course we can start it. And we can see that it's reinitialized again. And 9050 is there back again. So let's run this again. Let's imagine we have a service that we do not want to be running. So cron, for example, say we want to make sure that that is not working. Then we can simply disable cron. These run level messages, that is normal or what you get. And then if we do a status, this is disabled, but it's still running. So you have to still stop it. And then it is both disabled and no longer running. And of course it is possible to enable it again with this. When you enable it, you create a symbolic link from the system's copy of the service file, which is usually in /lib/systemd system. As you can see, it's here for this one, or in etc systemd system, into the location on the disk where systemd looks for auto start files. So usually etc systemd/system and then some target dot something dot something. So I want to enable that because we want that enabled. Another thing you can do is mask. Systemd also has the ability to mark a unit as completely unstartable. So that's either automatically or manually by linking it to dev null. And this is called masking the unit. And you would do that with the mask command. And then when you would try to run it, you would get an error message. You can unmask using the unmask command, as you can see here. And we can see here the unit file for cron. We can actually view that. So cat, we can do that for cron. And this is what has been loaded into the system. And tool. Systemctl list -unit -files space --type equals service. That is going to tell us what is enabled and disabled at start. So we can see if we can find anything that should not be there. You can see we've got the masked files enabled and the disabled. Look for anything that should not be there. Quit that. And we can just grep enabled if we like. Just see the ones that are active. Another command, journalctl. You can look at the boot log for anything that's in there. So we can add -b. That's the current boot. We can look through there. And if we want to look for a particular unit, so Tor as an example, see what was going on with Tor. There is a man page, obviously, for systemctl. You can check that out. If you're familiar with system V, not familiar with systemd, then there's a link here which can show you the equivalency of the systemv command and the systemd command. Or if you're on a system that is systemv, then you can see the equivalency commands here. So that's systemctl and journalctl, which can help you find items that are persistent as part of systemd.